Hi guys, hello. Please share this live so that people can join. It was a very short notice thing, so not a lot of people saw it. So it would be great if you can share with people that are in grade 10 but also 11 or 12, because this can help for all of that, for all those grades. So please, let people know. I'm just going to give it a few minutes. I'll start at like 4:05-ish, I think. So you can maybe grab something to drink, some water, some tea, get a snack. We'll get going shortly. Hi, hello. Hello, this is for grade 10. So it's a topic that's first taught in grade 10, but you do need to be able to do these same types of questions in grade 11 and 12. So I've labeled the live as grade 10, but you actually need to know this in 11 and 12 as well. Thanks for sharing, guys. If you can please keep doing that. I'm just going to give it a few more minutes. This was very short notice, me announcing this live. Not necessarily. I'm going to show you some examples where you can't use the exponential laws. There are two types of exponential expressions. So I'm going to just explain the difference between the two types. That's what we are doing today. So someone's saying here that it's very easy, you just need to apply the laws. So I'm just saying that there is a specific type of question where you can't do that. So I know what you're talking about. You are talking about like type 1, yes, where you just need to know the exponential laws. But then type 2 is where you can't use the exponential laws. So I'm going to go over the two types so that you can see the difference between them. You're very salty, hey? You may have done very simple ones in grade 8, yes, but the way that maths works is you learn something in grade 8, then you do it again in grade 10, but more complicated. Then you do it again in grade 11, but more complicated. You do it again in grade 12, more complicated. So yes, you do learn about exponents in grade 8, but you do learn about exponents in all years. Are you on there? Not. Oh, I'm not saying. I did exponential expressions in grade 8, and you're only doing it in grade 10. Sure.
Wys mir.
Grade 10, but also 11 and 12. I'm only going to start maybe 2 minutes after 4 because I just want to make sure that everyone's here. I said I was going to start at 4. I'm just going to give it 1 more minute. 1 more minute. It's not going to be a long session either. It's just going to be like half an hour. So just want to make sure everyone's here. Guys, if you can please share with your friends. I see 6 people have shared already. But yeah. Let's see. How does this app know I'm in grade 10? Yeah, it's the For You page, hey? That's how. Thank you for sharing, guys. That's great. When the clock hits 4:01, I'm going to start. Nice. Found on For You page. That's great. I'm so glad. Thank you. Writing about this tomorrow. Well, then you are in the right place. Okay, guys, it's 4. Yes, okay, calm down. It's 4:01. I'm going to start. So guys, this is just a quick session. Something that my kids often struggle with, is that they get an exponential expression, but they don't know exactly how to simplify it. So there are two types. So type 1, and like I said already, but I'm just going to say this again for the people that joined a bit late, is that when you are, what was I going to say now actually? Oh, you learn these in grade 10, but then also in grade 11 you need to be able to do them, and in grade 12. So I'm basically going to go from like the most basic ones and work my way up. So type 1 is where you are able to apply the exponent laws. Okay, so we are applying the exponent laws. Now guys, the exponent laws that we are going to apply are the following. It's the multiplication one, right? Where if you have the same bases and different exponents, you can simplify that by keeping that same base, but then adding the exponents, right? You also have one where when you are dividing, and you have the same bases, you can keep that same base but then subtract the exponents. And then the last one, we can actually use all of them to varying degrees, but the last one that comes up most often is this one, where you have an exponent inside the bracket and outside the bracket. So we are going to then multiply those exponents together. These are the top 3 laws that we are actually going to These are the top 3 laws that we're going to be applying. Okay, now when this type is basically when you are multiplying and dividing. That is how you figure out that it's type 1. So type 1 is multiplication and division type questions. Okay, so where you have, for example, let me just quickly find a nice example here that works out nicely. I don't want to just make one up and then it doesn't get to a nice answer. If we are looking at, for example, sorry, I should have done this beforehand. Okay, if we are looking at something like this, we have 3 squared times 3 to the power of n minus 1 times 3 to the 0. That is at the top of the fraction. And then at the bottom of the fraction, that is all over 3, or actually 9 to the power of n minus 1. Now guys, they're not going to tell you that you need to simplify this exponential expression by applying the exponent laws. They're just going to say simplify and you're going to get this question. So what you need to recognize is that you are multiplying, right? Here we are multiplying. There's a times and there's a times. And then because it's written as a fraction, we are actually dividing. Alright, so this is multiplying and this is dividing. So as soon as you see that you are multiplying and dividing, or it can just be multiplying or it can just be dividing, in this question we're doing both, then you are going to have to apply the exponent laws. Now guys, when you are multiplying, right, we do already have 3 powers here with the same bases, right? We have a base of 3 over there, a base of 3 over there, and a base of 3 over there. But this is another thing, guys. We know that this is actually equal to 1. Okay, so we don't really have to work with that further. We know that this is equal to 1, but these two that we are multiplying together, they already have the same bases. So if we wanted to, we could just add those exponents straight away, right? We can write 3 to the power of 2 plus n minus 1. Okay, we can write 2 to the power of 3 to the power of 2 plus n minus 1. So I'm reading the comments, so then I get distracted. I'm actually not going to do that. Okay, now at the bottom here we are dividing. Now guys, this division law only works. We can only use this law if we have the same bases. Now at the top we have bases of 3. At the bottom here we have a base of 9. That means that I can't actually simplify this. In order to divide, when you are working with exponents, you need to have the same bases. Okay, so I'm just going to go from the start again. You look at this question, you see that you are multiplying at the top, and because it's a fraction, you are also dividing. When you are multiplying and dividing, you need to be able to use these exponent laws, but what I'm trying to get to, and the point of this whole thing, is that in order to use these exponent laws, you have to have the same bases. That is the most important thing. So I was saying at the top we have the same bases already, but what about the bottom, right? What about the bottom? At the bottom we have a 9. That's not the same bases as at the top. So now you need to ask yourself, can you write 9 as something with a base of 3 so that you can actually apply this exponent law? 9 is the same as 3 squared, right? So that is what I'm going to do in the next step. So I'm just going to rewrite this 3 squared times 3 to the n minus 1. I'm not going to rewrite this because, guys, this is just 1. All right, times 3 to the power of 0. This is just 1. That's why I'm not writing it again. Over. Now, this 9 at the bottom. Like I said, because we want to use these exponent laws, we need to get them all with the same bases. I'm going to write 9 as 3 squared. I think we all know that 9 is 3 squared, right? So that is what we're going to do. We're going to write 9 as 3 squared, and that 9 was originally to the power of n minus 1. Okay, so we need to write that again. We can't throw away that exponent. That exponent must go with our 3 to the power of 2. Yes, exactly. Someone said 3 squared to the n plus 1, n minus 1, right? n minus 1, because we're using that n minus 1 over there. Bring the to the power down. I'm not sure what you mean by that, okay, but we're going to keep going. Now, guys, here, before we can actually now minus these exponents, I need to get rid of these brackets, and this is now where this law comes in, right? When you have an exponent inside a bracket and outside a bracket, the way to get rid of those brackets is to actually multiply those exponents together. Now, here, there's a 2 here, and we need to see that we have 2 terms here. So I'm going to have to actually say, yes, distribution, distributive law. I'm going to have to say 2 times n, but then also 2 times negative 1. That is a very common mistake. Yes, we multiply. This is a very common mistake, guys, that people actually just want to multiply the 2 by the n. But you have to multiply it by the n and by the negative 1. That is very important. Okay, so again, I'm just going to rewrite my numerator. I'm not going to do anything there yet. You can add them together so long if you want to. All right, I'm just going to do one thing at a time so that people don't get lost. So I'm just sorting out my denominator first. So I'm going to say 3 to the power of 2 times n is 2n, and 2 times negative 1 is negative 2. Okay, now I can multiply and I can divide because I have the same bases. I have a base of 3 and a base of 3 and another base of 3. Okay, so now someone is asking, can you do a long one with lots of letters? Yes, I will. Okay, now guys, what I'm going to do is I'm actually going to write my answer, or not my answer, my next step with one base, right? Because when I do this multiplication, see, multiple bases, I'm going to keep the same base. Okay, so for this multiplication, I'm going to say 3 to the power of 2 plus n minus 1. Because when you multiply and you have the same bases like we have here, you keep that base and you add the exponent. So that's what I'm doing. I'm saying 2 plus n minus 1. Okay, but now guys, this is what we get when we are multiplying at the top. But now when we divide, what do? When we divide, we minus the bottom exponent. We're going to minus this 2n minus 2. Now, something that is also very important is because you are subtracting 2n minus 2, this whole denominator, this whole exponent here, you have to put that in brackets. Okay, highlight that or something, please, guys. That's very important. People always forget to do that. Okay, it's very important. Because you are dividing by this whole power, you have to minus the whole exponent. Okay, and to do that, we put that in brackets. All right, now I'm going to start simplifying things. Here, 2 minus 1 is just 1. Okay, so I'm just simplifying that. I still have my plus n. This negative 1 I need to multiply into the brackets here. So I'm going to say minus 2n, and then negative times negative 2 is positive 2, right? A negative times a negative is a positive, and then you have that 2 there. And now we can finally fully simplify. So we have our same base, which is 3. All right, I like putting the n's in the front, but it doesn't really matter. 1 plus 2 is 3, and 1n minus 2n is negative n. Okay, and you can usually leave your answer like that. Why does the number remain 3? Because, guys, if we're looking at these exponent laws, right, that is what's happening. Every time we multiply, we have the same base. See, that a doesn't change. It was an a and an a. Now, when we're putting it together as one base, it stays an a. All right, so that is what I'm doing here. When I'm adding these exponents together, the 3 doesn't change. I'm just adding those exponents. Okay, I'm using this law here, where you have the same bases, then when you put it together as one base, you don't change that base. It stays a base of a. Okay, so that's one example, guys. I'm quickly going to do one that is a bit more complicated. Someone asked for a more difficult one, so let's look for a nice one here. Okay, I'm going to do, this is again a fraction, so I'm just first writing the numerator, so 5 to the 2n plus 1. I'm actually going to do it underneath because there isn't really enough space on the side. Let me just move that page down. Okay, number 2, 5 to the power of 2n plus 1, and that is being multiplied by 15 to the power of n minus 1 times 3 to the power of n, and then in the denominator we have 125 to the power of n times 3 to the n minus 1. Sorry guys, I'm mixing my times and my commas here. It's not a comma actually, it's a dot. All right, that means multiplication. So grade 11 is the stuff. You have to do this in grade 11 as well, but you learn it in grade 10 for the first time. Okay, so that's why this thing is called grade 10, but it's actually 10, 11, and 12. Okay, so now guys, again, we need to look at this question, and remember the question is just going to say simplify. We need to know what we must do. So we see, okay, I'm timesing. All right, I am also, sorry, let me just draw in my line. Right, that's better. Remember, when something is written as a fraction, you are actually dividing as well. Okay, so now we are multiplying and we are dividing. So I'm just going to actually write these laws again because they are off the screen now. And guys, it's so important that you know these laws, right? You learn them in grade 8 for the first time, maybe in grade 8. They don't always do it in grade 8, but definitely in grade 9. And guys, it is so important. Now you are in grade 10, 11, 12, and you still need to be able to apply these laws. Okay. So again, guys, I'm just going to focus, or I'm just going to remind us that if we're starting with the same base, the answer keeps that base. So we're not going to change the base, right? We have that base and that base. We keep the same base. If you want to do this on your own, feel free. Maybe turn down the volume. And you can do it. I'm going to go through it step by step, so you will be done before I am done. Okay. Now, guys, in this case, as we can see here, we don't have the same bases. We have a base of 5 over here. We don't have any other bases of 5. We have a 15. We have a 3 over there and a 3 over there, and then we have a 125. Okay, so we have multiple different bases here. Now, I actually want us to go back up to the first heading where we said type 1 is where you apply the exponent laws when you're multiplying and dividing. Guys, the important thing here actually is that we need to get our bases to be the same, yes, but the way to do that is going to be to get prime factor bases. Okay, if you write all of your bases in terms of their prime factors, that's going to be the easiest way. That's going to be the best way to make them simplest and to make them all the same. Yes, for prime bases, exactly. So that is what we're doing here. We're going to do the same thing. 5 is already a prime number, so I don't need to do that, all right? I don't need to change that. That is already written as a prime base. 15, I'm sure we all agree that 15 can be written as 5 times 3, All right, 15 can be written as 5 times 3. So I'm actually just quickly going to rewrite this first one. Like I said, that is already a prime base, so I'm not going to change it. 15 is 5 times 3. So I'm basically replacing the 15 with a 5 times 3, all right, to the n minus 1. Times the last one here, 3 is also a prime number, guys. So 3 is already a prime number. So 3, I'm not going to change that, 3 to the n. Okay, so we're basically changing all of the bases that aren't prime numbers, and we're rewriting them as a product of their prime numbers. Okay, now 125 is a bit more difficult, but 125, hopefully you guys know that 125 is 5 to the power of 3. Okay, so 125, if I want to write that with a prime base, that is 5 to the power of 3. Okay, that's one that you're actually supposed to know. Okay, it's okay if you don't know that, but just try and remember. Okay, that 125 is 5 to the power of 3, and then you put that to the power of n, because it was already to the power of n. We can't throw away that original exponent. And then again, times for this last one. 3 is already a prime base. It's already a prime number, so I'm going to leave it as 3, and there we go. Okay, so now we have actually written all of our bases as products of their prime factors. Okay, next one. Next up, now before we can actually start applying these first two laws, multiplying and dividing, we need to first apply this bottom one. We need to get rid of all of our brackets. Okay, so now for our brackets, remember, we always take the exponent inside the bracket and outside the bracket, and you multiply them together. Okay, so for this one, again, that one is already perfect. I'm not going to do anything else. There are no brackets there. I don't have to multiply anything together. All right, so I can just rewrite that. Times. Now guys, here, this is actually another exponent law that we haven't touched on yet. I hope that looks familiar. If you have multiple bases in a bracket, right, and then an exponent outside that bracket, you need to raise all of the bases. It's not always 2, it might be more than 2, it can be 3, 4, 5. You have to raise all of the bases in that bracket to that exponent. So you're going to say that this is a to the power of m, and then also b to the power of m. Alright, so in this case we actually have to apply that law, because here we have 5 times 3. Okay, so we're going to say 5 I'm raising to that exponent, n minus 1, times 3 I'm raising to that exponent, n minus 1. Okay, now I've gotten rid of those brackets. Then times 3 to the n. Again, I'm not touching that because that's already fine. That is already a prime base and there are no brackets there. Okay, we are nearly ready to multiply and divide, guys. 5 to the power of 3 now needs to be raised to the power of n. What do we do if we have an exponent inside and outside a bracket? We times them together. So we're going to say 5 to the power of 3 times n, which is 3n. And then times 3 to the n minus 1. Now, guys, we have all of our bases are prime numbers. We have multiple bases that are the same, but we have different ones as well, right? So this is different from the previous question. In the previous question, we only had bases of 3. In this question, it's a bit more complicated because we have bases of 5 and then also bases of 3. So, guys, it helps quite a bit if you actually take a highlighter and you highlight the ones that are the same. Or you can circle them or underline them. I'm just looking for some highlighters here quickly. Okay, I will use this pink one, and then let's see if I can find a different one. I'm gonna have to use this kind of purple colored one. Okay, so I'm gonna highlight all the 5s in pink, so those ones I'm going to have to put together. Alright, when you multiply, you add the exponents. When you divide, you subtract the exponents. So that is going to become, guys, all with one base. Remember, when you're applying these laws, you keep that base. So these 5s, when I multiply and divide them, I'm going to keep my base 5. I'm not going to change the base. Alright, so here you're going to do 2n plus 1. Now these two you are multiplying, so you need to add that second exponent. You need to add that n minus 1. The one at the bottom, what are you doing here? These two you multiplied, but this one you're dividing by. So that one that you are dividing by, you actually have to subtract that minus 3n. Okay, now from here, what you are doing is we still have bases with 3's as well, or bases of 3's. So that one and that one and that one. Sorry, this highlighter is a bit dark, but it's the only other one that I have. All right, so 3, 3, and 3. Again, guys, here at the top, I'm multiplying, so I'm going to add them together. At the bottom, I am dividing, so I'm going to minus this one. Oh, thank you so much for the roses. That's lovely. All right, so now you are adding these ones and dividing. Now, guys, what you're going to do here, right? People often say, what must you do with the 5 and the 3 now? Do you add them? What do you do? Do you times them? Guys, there's no addition here. Hey, we are actually multiplying all of these together. If you look at this, I'm saying all of this times all the 3's, right? So when you actually do your long line of exponents, you're going to times by the 3. Okay, so we're going to do 3, that same base. I'm doing these laws. When I multiply and divide, I don't change the base. I'm going to keep the same base. So I take this exponent, n minus 1. Because I'm timesing these, I need to add that top exponent, that n. And at the bottom, I'm going to do one with addition just now. At the bottom now, I am dividing. So I need to minus by this exponent. Now, just like in the previous example, because there are multiple terms in this bottom exponent, I need to minus both of those terms. So I have to put those two terms in brackets. That is very, very important, guys. Okay. Next up, now we're going to simplify. With our base of 5, let's see. Let's take a look at what we have here. We have 2n plus n. That's 3n minus 3n, that's 0. Okay, so that's quite nice, guys. Those n's actually cancel each other out. So I'm just going to draw a line through them just so that you can see that 2n plus n is 3n minus 3n again is 0. Okay, so all of those n's are just cancelling out. That's lovely. And now if we're looking at the numbers, we have 1 minus 1, which is also 0. So that first exponent, right, all of those, when I actually simplify it, I'm getting 5 to the 0. Okay, that's interesting. Let's do the same thing for the 3's. 3, here, what I need to do first, though, before I can simplify the whole thing, is I need to multiply that minus n. Okay. If it is 0, should you raise your base to 0? So you have to write that at 0. I'm worried that if you don't write anything there, you're going to think that it's just a 5. Okay, but 5 to the 0 actually isn't 5, right? 5 to the 0 is actually 1. Okay, so you do have to write that 5 to the 0 there at first. I'm not going to write it as a part of my final answer. Okay, you'll see now. So now, guys, here, we are going to multiply this negative 1 into the bracket, but what I can do so long, I have n plus n, I can add those two together so long. Thank you for the rose, that's lovely. All right, n plus n again is 2n. Okay, I have that minus 1. Now this negative 1 I must multiply into this bracket. Okay, so negative 1 times n is negative n. And here I have a negative 1 times a negative 1, which is a plus 1. Okay, we're almost there, guys. Last step. 5 to the 1 now is just 1. Okay, you don't actually have to write that 1. You can just, let's put it in brackets on the side. I think I'll do that, right? Remember that 5 to the power of 1. Anything to the power of 1, sorry, anything to the power of 0 is just a 1. Okay, so you don't have to write that again. Over here we have a 3. Now 2n minus n is just n. And then we have minus 1 plus 1, which is 0. Okay, so all that's left actually is 3 to the power of n. That is the final answer. Okay, guys, but basically what I want you to take from these two examples that we've done now, this is type 1, all right? When it's a multiplication and a division question, you need to apply your exponent laws, and in order to apply the exponent laws, because you need to have same bases for these laws, right? You have to write all of your bases with as products of their prime factors. Okay, so that is type 1. Let's move on to type 2. Now, guys, what I'm going to do is I'm going to post these notes. I'll post a recording of this live. Sorry, let me just turn the page. I'll post a recording of this live to my YouTube, but I'm also going to post pictures of the notes on my Instagram. Okay, so go take a look. If you maybe missed something, you can go take a look there. Okay, now type 2. And these are usually the ones that people struggle with. And these are the ones that people have been asking me for. Type 2 is where you are adding and subtracting. So plus and minus. Now guys, for these plus and minus questions, you are always going to have to factorize. Okay, and that is what people have struggled with or have problems with. Sorry, again, I'm reading the comments, so then my words don't work as well. Okay, so I'm just going to show you this example. Okay, we have 7 times 2 to the x minus 3 times 2 to the x plus 1 over 2 to the power of x minus 2 to the power of x minus 1. Now guys, the thing that's happening here, right, is that you have 2 terms at the top. Do we remember from grade 8? Pluses and minuses separate terms. Okay, so here we have a minus. We have a minus there. So we have 2 terms. And at the bottom we also have 2 terms because there's a minus there. Now guys, the important thing, the most important thing, is that you cannot cancel out if you have more than one term either at the top or at the bottom, or both, like we have in this case. Alright? So I'm going to write that as a note on the side. That is very important. You cannot, I'll put cannot in capital letters because it is very important and lots of people make this mistake. You cannot cancel out. Let's see, is that still on screen? Only just. You cannot cancel out over multiple terms. Guys, what does it mean when you're cancelling out? What are you actually doing? When you are cancelling out, you are actually dividing. I'm not sure everyone knows that, right? Cancelling out is actually the same as dividing. Okay, so when you are looking at this line means dividing. So this is saying you have to take this whole numerator, right? 7 times 2 to the x minus this whole thing, you need to divide by this whole thing. So if you just decide, okay, nice, I'm going to take that 2 to the x and I'm going to cancel out that 2 to the x. You've only divided the first term here by the first term here, which is not what the question is saying you need to do. The question is saying that you need to take both of these terms and divide by both of these terms. Alright, that's very important, guys. That's why you cannot cancel out. And actually what they do at most schools is as soon as you do this, right, as soon as you cancel this out, they say that's a breakdown. You get 0. Okay, they don't even look at what you did after that because that's a very bad mistake. Okay, you cannot cancel out over multiple terms. So what we need to do here is we need to use factorizing. All right, we need to use factorizing to turn multiple terms into one term. That's the purpose of factorizing. Okay, that is why we're going to factorize. We're going to use factorizing to turn multiple terms into one term. And then we are going to cancel out. That's actually why you learned about factorizing in grade 9, guys, so that you are able to do this, so that you are able to take multiple terms, turn those multiple terms into one term, so that you can then cancel out. Okay, that's actually the purpose of factorizing. So what we're going to look at here is some of you might be able to factorize straight away and see easily what is left. But I suggest that if you struggle with this kind of work, you need to first split up these two exponents here. Whenever you have exponents with multiple terms, you're going to have to split those exponents up. That is just going to make the factorizing step so much easier. Okay, so here, just again, when you see this question, you're going to see, oh, I'm minusing now. I don't have an exponent law for minusing, right? We have an exponent law for multiplying. We have an exponent law for dividing. We have an exponent law for when we have brackets with an exponent inside the bracket and outside the bracket, but there is no exponent law for adding and subtracting. So as soon as you see a plus and a minus, you are going to have to factorize. Okay, so that is what you need to remember, guys. Type 1 is where you're multiplying and dividing. So you get your prime bases and then you apply your exponent laws. Type 2 is where you are adding and subtracting. There are no exponent laws for when you're adding and subtracting. So what you have to do is you have to factorize. Okay, now what I'm just going to do first, I'm going to show you how I'm going to split up these exponents, and then I will just explain to you why I can do that. The first one I'm going to leave as it is. I don't have to split up this exponent because it's just an x. Okay, the second one I am actually going to split up. I'm going to split that 2 to the power of x plus 1 into 2 to the x times 2 to the 1. And guys, this is coming back from this exponent law, right? If I asked you this question, if I asked you to simplify that, okay, we're just ignoring this for now. If I asked you to simplify this, you would say, oh, that's so easy. I have the same bases, right? Both of them have a base of 2, and I'm multiplying. So what am I going to do? I'm going to say, let's keep that same base, and we are going to add those exponents. Right? That is the first exponent law that you guys are very used to using by now. Now what we're doing when we're splitting this exponent up, we're going backwards, right? We're going from one base with multiple terms in the exponent to 2 separate bases, but it's still the same base, right? That was a base of 2. This is still 2 bases of 2, but now I'm splitting that exponent up into an x, and then because that's a plus, it's a times, and then a 1. Okay, so I'm going backwards, guys. Here, you do need to be able to actually apply those exponent laws backwards, which is what I'm doing now. Okay, you all are fine with this. You all, I'm sure, are fine with 2 to the x times 2 to the 1 is equal to 2 to the x plus 1, right? You're all fine with this. If you have the same bases and you're timesing, you add those exponents. Now we're going backwards. Now I'm saying if you have one base with multiple terms in the exponent, you can split that up into separate bases, but it's still the same base. It's still 2 bases of 2, and then there's an x, and then there is a 1. All right, so there's the x, there's the 1. That's where that's coming from. So guys, that is how you split your exponents up. Okay, that is the first, that's the numerator, sorted. Okay, we've split that exponent up. Let's do the same thing in the denominator as well, because in the denominator here we have another exponent that has multiple terms. Okay, so this first one I'm going to leave. This exponent has only one term, right? It's just an x. So I'm going to leave that, 2 to the x, minus, this one again has multiple terms in the exponent, so I'm going to split it up. Okay? I'm going to take one base of 2 with that x, 2 to the x, times a base of 2 with a negative 1, because now negative 1 there. Okay, that is x minus 1. So I'm going to do x and negative 1. Okay, now guys, I want you to take a highlighter. Please highlight the 2 to the x's that you see, because now we're going to take out a common factor of 2 to the x. There we have a 2 to the x, there we have a 2 to the x. Right? We're going to factorize, guys. Remember the purpose, like I said, of factorizing is to go from multiple terms to one term so that I can cancel out. So I'm going to take this 2 to the x out as a common factor, right? I'm going to write it in front. I'm going to open my bracket. And in the bracket, I'm going to say, what do I get when I take away that 2 to the x from my first term, right? When I divide by 2 to the x, when the 2 to the x goes away, what's left? A 7, right? Minus. Sorry, there are kids shouting outside. I'm not sure if you can hear them. From the second term, there again is a 2 to the x, right? Which I'm taking out now as a common factor. So I'm taking this whole thing. I'm dividing by 2 to the x. What's left? 3 times 2. What is 3 times 2? That's 6, hey? Okay, so that is what's happening there. Guys, how many terms do I have now? 2 to the x times 7 minus 6. That's one term. There we've gone from 2 very complicated terms to one term that is much simpler. Okay, just by taking out that 2 to the x as a common factor. In the denominator, we're going to do the exact same thing. We're going to, let me just highlight the 2 to the x's. There we go. All right. I'm going to, again, take out 2 to the x as a common factor. I'm going to write it in front. In my brackets, I'm going to write, what do I get when I divide each term by 2 to the x? Now, guys, if you have 2 to the x and you're dividing it by 2 to the x, what is that? What is that? What is 2 to the x divided by 2 to the x? It's just 1, right? So that is what goes in brackets. Minus 2 to the x. Now here, remember, I've taken out the 2 to the x as a common factor now, right? So I'm looking at this term now. What is this whole term when I divide it by 2 to the x? What's left when I take away that? 2 to the negative 1. Now, guys, what is 2 to the negative 1? It's a half. Okay, you might be a bit, you might be a bit rusty on negative exponents, but 2 to the negative 1 is equal to a half. All right, guys, I do have a YouTube channel. You can just go check in my bio. Okay, I do have a YouTube channel with lots and lots of lessons. Now, guys, the great thing about this is that we've gone from 2 in the numerator term. We have 2 terms in the denominator to 1. So now we have 1 term over 1 term, which means we now can cancel out. If there's something at the top that is the same at the bottom, we can cancel those out. Isn't that great? We have a 2 to the x and a 2 to the x. There we go. There they go. Remember, when we're canceling, we're actually dividing, right? So now we're saying 2 to the x divided by 2 to the x is just 1. Okay, so those two actually cancel each other out. And now, guys, I'm just left with numbers and I can work that out. Okay, so now we're going to say 7 minus 6 is 1. And at the bottom of the fraction, I have 1 minus a half, which is a half. Right? What do we do when we divide by a fraction? We have to tip and times. So I'm going to say that this is the same as 1 times. Now, if I do 1 over 2 and I tip it, I'm going to get 2 over 1. Right? And what's that answer, guys? 1 times 2 over 1, that is just 2. Okay, there we've done an example. So, guys, I'm quickly going to summarize because I do have to cut this live now. All right? I will put this on my YouTube channel. It will be there tomorrow, definitely. The 2 types, all right? So, type 1, I'm just going to summarize again what we actually need to do. Type 1, when you times and divide. Okay, the first step is you are going to write your bases as products of their primes. Prime factors. Let's use the correct terminology. You are going to write bases as products of their prime factors. All right. Step 2, you are then going to apply your exponent laws. And I did write them on the side of the example, so you can go take a look if you copied those down. But you are going to apply those exponent laws, the multiplication laws, the division laws, the bracket laws as well. Okay, that is if it's a multiplication and division question. You're going to write the bases as products of their prime factors, and then you're going to apply the exponent laws. Type 2 is when you are adding and subtracting. Right, for type 2, when you are adding and subtracting. Step 1 is you are going to split up exponents with multiple terms. So like a 2 to the x plus 1, that x plus 1 you're going to split up. Right? Split up exponents with multiple terms. Step 2, right? You are then going to factorize at the top or the bottom, or maybe in both. All right, we did it in both for this one. Okay, you're going to factorize. And then step 3, you are going to then, after you factorized, cancel out and simplify. All right, actually calculate that answer. And that's it, guys. Those are the two types of exponential expressions, how to identify them and how to decide what method you are going to use to solve them. Okay, I have to go now, guys. I hope that this was helpful. I am going to do more shorter lives coming up. I used to do really long ones, but yep, I also think people's attention span is not that long, so mine as well, especially after a long day at school. So I'm going to do more of these shorter lives. Make sure to follow so that you get notified when I go live again. And thank you so much for joining. I hope that this was helpful. Also, thanks for the gifts. I really appreciate that. Bye, guys.